Today.
I'm not that sure, sir. I think he's joining soon.
He'll be joining soon, but he'll be coming online only, I believe, because of the weather, right?
Yeah, yes, coach. I'm here.
So let me close the garage door first. Okay, here comes David. Okay, so we have Davik, Dheera, Praneeth, Sahit. Yeah, that's it. And myself. So let's get started. So Dheera, I mean, again, there are things that we have done before and you are joining in the middle of the class. You will think that, okay, I'm missing something. How will I catch up? Don't worry about it. Whatever we'll do, we will keep going in loop. Like Praneeth has been with me for some time and he has probably gone through some of the concepts probably 2 or 3 times. And every time we go through the same concept again, it gives us the opportunity to revise and catch up on those things. Okay, so math is all about practice and learning things. So there are 13 units in pre-calculus and we'll go through each of those units at least 2 iterations, if not less, in next 1.5 years. Okay, all right, so let's get started. Hey Vishal, so do you guys remember what we learned in the previous class? I'm trying to check everybody's memory, including mine. What did we learn in the previous class? Anybody? Can anybody help me recall? Except Dheera, obviously for Dheera it's first class, he would not know. Davik, Sahit, of course Praneeth, but Praneeth has watched the video, so yeah. Everybody except Dheera should be able to give it a try. Now, see, I am getting old, so I have all the reasons to forget things, not you guys. Your brains are much, much younger than mine. Hey Samriddhi. Okay, so let me help you guys recall. So basically we looked at the basic concepts of unit circle, and then we also tried to convince ourselves that why do we need to learn about unit circles and how it is different from the basic trig functions that we are aware of. And then we learned about some of the concepts relating to symmetry and periodicity using unit circle. Do you guys remember now? Why there is a pin drop silence kids? Nobody remembers? Okay, so then that becomes a good news for Dheera. I will probably redo some of the things real quick. So Dheera, again, I'll call out your name a couple of times because this is your first class. So just to make sure that I'm saying something which makes sense to you as well. Yeah. So Dheera, tell me, how comfortable are you with the unit circle concepts? Are you aware of it? You have come across it before, or it's something sounding new to you?
It's something new. We haven't done that yet in school.
Okay. Okay, so I will touch upon unit circle concepts. We will try solving some problems. If it sounds new, surprising, difficult, complicated, don't worry about it. My job is to make things simple, okay? Because the biggest problem that I have in life is lack of intelligence. I'm not very intelligent. Let's come to things, okay? So, unit circle, a circle with a radius of 1. That is why it is called unit circle, okay? And I'll not touch upon each and every basic concept, Dheera, but I'll touch it enough so that you are comfortable, okay? So, when you talk about unit circle, it's a circle with radius of 1. Now, unit circle gives us one very important concept, and that says that if this is a unit circle, meaning the radius of this is equal to 1. Be it 1 inch, 1 centimeter, 1 meter, 1 mile, doesn't matter. 1. Okay? That's why it is called a unit circle. Now, unit circle says if you pick up any point on the perimeter of the unit circle, let's say I picked a point P. When I join the origin of the center of the circle with this point, and this center happens to be the origin of the coordinate plane also, this is the x-axis, this is the y-axis. So any point P on the perimeter, if you join that with the center of the circle, and that makes an angle theta with the positive x-axis, then the coordinates of P would be cos theta, sin theta. Okay. So again, a question to Dheera. So Dheera, how comfortable are you with the basic understanding of trig functions? So Katua.
I think I'm pretty comfortable.
Very comfortable. Okay, that makes my job a little easier. Okay. So any point on the unit circle along the perimeter of the unit circle P will have coordinates as cos theta, sin theta. Now, if you want to see any point on the unit circle, at any point in the coordinate plane, let's say this is x and y, and I'm saying that unit circle says x equal to cos theta and y equal to sin theta. Okay, that is how we are relating it with the concepts of unit circle. And let's look at it. From this point, if you drop a perpendicular, meaning this is 90 degree. Now you are looking at, let's say this is O, this is P, and this, let's say this point is Q. Then OPQ is a right angle triangle, and you can apply SOHCAHTOA to find out. So when we are saying this is x, meaning I'm talking about this length as x. When we are looking at y, I'm looking at the y coordinate, this length. Correct? Now, if you relate that with the SOHCAHTOA concept, x over this r in this triangle PQ, OPQ, if you see x over r, which is 1, will be equal to cos of theta, because cos of theta is adjacent side by hypotenuse. This is adjacent side against this angle theta, and this is a hypotenuse which is 1. So this is equal to cos theta. And from this you can see x by 1 is nothing but equal to x. X equals cos theta. Okay. Similarly, y over this, and in context of this theta, y over hypotenuse is nothing but sine. Opposite side by hypotenuse will be equal, y over 1 will be equal to sine theta. Okay. So that means y equals sine theta. So that is what unit circle says, nothing new. It says any point on the perimeter of a unit circle will have the coordinates as cos theta, sin theta, where theta is the angle that this line makes with the positive x-axis. Is that okay, everybody? Dheera, okay?
Yeah.
Okay. So this becomes a generic rule for us that, since we saw one point in the first quadrant of the quadratic plane, first quadrant of the coordinate plane, you can generalize this, and if you are picking up, let's say this point is r, the coordinates of this point r will be again cos theta, sin theta, where theta will be the angle this point, this line makes with the positive x-axis. Your theta has changed. Okay, so this will be our generic rule to follow. Okay, so we talked about the concepts of symmetry and periodicity. Now, just to make sure that everybody is able to recollect. Everybody able to hear me okay, right? So far? Samriddhi, David, Sahib, Dheera, Vishal, Pranit, everybody? Okay. So, what symmetry said is, symmetry is a concept. Somebody got dropped off. Okay, sorry. So, concept of symmetry is this. Let's say this is your unit circle, and this is your x-axis, this is your y-axis. Okay. Let's say you picked a point. Let's say this is the same point P, and you join this. This is the angle theta. So, when you're talking about symmetry with respect to this point, you are doing nothing but you are just extending it. This line. so that it meets some point on the perimeter in the third quadrant. Similarly, if you're talking about, let's say, let's do this theta, negative of this theta, meaning we are moving clockwise. So this will be minus theta, okay? So symmetry of that would be when you extend this line. So I'm not going to derive it again because we did that in the last class, and even if we derived it together, I'm pretty sure that nobody will be able to remember this. We will derive it on the fly, okay? So that way it will be easy for Dheera and it will be less bothersome for everybody else who is scratching their head to recall what we learned in the last class, okay? But symmetry says, okay, if you have any point, you're joining that with the center, extend that in the opposite direction wherever it meets. So here this is theta, you're talking about this angle is pi radian and plus theta. So whatever you know with respect to cos theta, this is cos pi plus theta. Whatever is here theta, this is sin pi plus theta, okay? Similarly, when you reflect it across the x-axis and make it minus theta, and when you extend this way, so this angle from here to here would be, here to here is pi, and this angle will be again theta. Same value as this one, okay? And that's what we saw. So we will deal with all these concepts, okay? If we know what is cos theta, what will be the value of cos pi minus theta? What will be the value of cos pi plus theta? This is what the concept of symmetry helps with, okay? And let's not worry about it right now. Even if you remember or don't remember, there's nothing to worry. Is everybody okay so far? Somebody okay? Davik? Praneeth, everybody okay? Okay. So, if not okay, don't hesitate to ask. Now, this was on the symmetry concept. Now, what was periodicity? Like we dealt with theta, pi minus theta, pi plus theta. Here, periodicity talks about a perpendicular line. This is theta. This line is making angle theta. If you drop a perpendicular on this one, let's forget about this thing, okay? If you have dropped a perpendicular on this one, this whole angle will be this theta plus the 90 degree. So the concept of periodicity deals with how do you relate sine of theta with sine of pi by 2 plus theta versus sine of pi by 2 minus theta versus cos of pi by 2 minus theta versus cos of pi by 2 plus theta, and so on and so forth, okay? And I'm not flexing right now. I'm just telling you that these are things that will come across. So now, simple thing, symmetry, when you're talking about, you're extending the line and trying to find out if this is theta, what will be the value of pi plus theta versus pi minus theta. Similarly, if this is theta, periodicity says, take a perpendicular on that line, make a perpendicular on that line, and figure out how do you relate sine theta with sine pi by 2 plus theta and pi by 2 minus theta, and so on and so forth. And we'll come across all those things in a very simple way without memorizing all this complicated looking thing. But I hope I could help everybody except Dheera to recollect what we did in the last class with respect to symmetry and periodicity. And to Dheera, at least you'll be comfortable when you hear the term symmetry with respect to a unit circle or periodicity with respect to a unit circle. Yeah? And I'll muddle the water enough so that it becomes more and more familiar to all of us when we do some problems. Yeah? Are we good to get started with some interesting problems? Okay. Dheera, are you ready to jump into the water now? Okay. So, there's a very interesting concept around swimming. Some people say that you learn all the technique of swimming and then you jump into water. Some people say you jump into water, you'll end up learning swimming. And what we do is we do a hybrid, meaning we learn a little bit of concept, even if it's not enough, we'll jump into water and then we'll keep peeling off the onions. Let's see what I'm trying to navigate you guys towards. Let's look at some problems. So I had, okay, now guys, I have an opportunity to annoy you guys one more time. So Dhira, this is something that Praneeth hates me for, but I don't have a choice. Every kid, when they join the first class, see, he's crying already. So every time a new kid joins the class, I tell them one concept that I want you guys to make it part of your life. Who wins the race depends on who ran the best. And we are not doing a rat race here. This is just a correlation of the concept that we apply. This RAN, if you break it down, it stands for read, analyze, and N stands for Nike. What does Nike say? The slogan of Nike is just do it. So what I'm saying is, by this, what I navigate you guys towards is, whenever you have a problem to deal with, read it once, twice, 3 times, and that will make the problem much more easier, much more familiar to you. And then you start thinking, okay, this is a problem. I understood what has been asked, what is to be done, and the other things I know. So this is the approach I'm going to take. So you are making your mind, you are creating your blueprint, and then you go to Nike, just do it. So it's a 3-step process. Read the problem, analyze, come up with your plan, and then you do it. Most of the times when we go wrong, the primary reason for that is we jump onto solving problems without thinking about it, without reading the problem enough. Okay. So, and that's why I bore everybody to repeat this. Even if Praneeth has heard it 50 times, I want him to hear it 51st time so that it becomes a part of life. Not only for Praneeth, but for David, Sahid, Dhira, Samriddhi, Vishal, everybody. Okay? So now, so let's apply that. It's not just about preaching, it's about practicing it as well. Let's look at it. So we have a problem that we are trying to solve. So, and everybody has to try doing it. Let me first draw this one. Okay. On the following unit circle, theta is in radian. So this is a unit circle. So that, as you can see, every radius is given as 1. So this is 1, this is 1, this is minus 1 because this is along the negative x-axis. And this is minus 1 because this is along the negative y-axis. This is more like coordinates, okay? But this is a unit circle. Now it says, which two of the following expressions are equivalent to cos of theta? So you see what is the theta? This is this angle theta is the angle that it is making with the positive x-axis. Okay? And you are given 4 options. You have to choose 2 options. Okay? And this is where it will get actually interesting. So even if you know unit circle, you don't know unit circle, you will be able to find it out. I mean, obviously you have to relate it with the unit circle concepts, but we will find it out. Okay, so this is a typical, one of a sample problem that you might come across. Can everybody see the board okay? So right now I'm in the process of reading the question again and again for you guys. So this says, this is a unit circle and this is the angle theta that it makes with the positive of x-axis. And then you are given, it says, which of the below, I mean these 4 options are equivalent to cos of theta. You have 4 options, cos 2 pi plus theta, cos pi plus theta, cos minus theta, and cos pi minus theta. Okay? And this is where you will end up applying the concepts of symmetry and periodicity. Think little creative, think about it, and at least try. And here the question says there are two right answers. Okay, we might not be able to solve all the problems that are sent, but we'll solve the problems in a way that we get very, very clear about how do we go about solving these problems. Okay, Did everybody hear the question? Okay, or you want me to read it one more time? Davik, very quiet today. What happened? All good? Yes, Praneet.
I have a lot of background noise, sorry.
I'm sorry, Vita?
There's a lot of background noise, so I'm staying muted for a while.
No, that's okay. I mean, as long as you guys are engaged, I'm fine. Let's see what Praneet says. Yeah, Praneet.
I think I can do
Yeah.
Say that again.
B.
Okay, B is one option. But the question bluntly says that there choose at least two answers. There are two answers actually. So let's say B is one option. Think about what could be the other option. Vishal, Samriddhi, tell me what is going on in your mind right now. Sahid and Dheera also. So I'm throwing you in water, Dheera, so that you can learn swimming on the fly. Dheera thinking.
I don't really know.
You know, it's a good bit, right? It's fine. And everybody knows what does beta mean, right? Beta means child, okay? You guys are all my kids. That's how I treat everybody. So don't, if I say something which you don't understand, you're okay to even ask, sir, what does beta mean? Okay? Alright. So it's okay, fine. So Dheera, for you, while your friends are thinking right now, there's one more concept or approach that we follow is, when you are dealing with this kind of problem, I mean your SAT exam or pre-calculus exam will be full of multiple choice questions. MCQ is what you guys call it, right? So it's not just about solving and finding the answer, it's also about eliminating the unwanted answers, okay? So let me give one quick clue here, okay? Let's say we have 4 options and the question says there are only 2 right answers, okay? So Dheera, if I ask you, if this is angle theta, what will be my minus theta? Any idea?
Not really.
It's okay, but it's fine. We are learning it together. So the way it works in trigonometry is, when you are measuring theta, when any angle, you are measuring anti-clockwise. Okay? So that's when it is positive. When you are measuring it clockwise, that is when it is negative. So same value, if you reflect it across this x-axis, same angle value, but clockwise would be negative theta. Okay?
Okay.
So now here, let me give you guys one clue. Will cos minus theta be equal to cos theta? Let's look at it. Cos theta, let's say this is theta. So pi, this is pi. Let's call this as this whole theta equal to 2 angle. So you see a pi here, pi radian, okay, and then some angle. Let's say pi radian plus this angle is, let's say, x, okay, not x. I'll give it some other name. Let's say alpha, pi plus alpha. Now use the concept of symmetry, meaning you are extending this line here. Okay, so if this angle is alpha, this angle will also be alpha. Is that okay? Shahid, do you agree? Samriddhi? Okay, Dheera also agrees. Wonderful. Because these are opposite angles, right? So let me clean up some mess here. It looks very dirty. So this is alpha, and this whole thing together is theta. So if somebody says theta is 180 plus alpha, what will be minus theta? So meaning I will go 180 here in this direction and then alpha. Basically, I'm talking about reflecting this here. Now look at this. Cos of theta. Cos of theta. So this angle is theta, and this angle here, when you are going this way, this is cos, and this whole angle from here to here is minus theta. So this point's x coordinate is what is your cos theta. In any point, right? Here, what will be the coordinate for this point? It will be cos minus theta and sine minus theta. Yeah, like what we saw with respect to unit circle, right? Any point. This angle is minus theta because we travel from here 180 degree plus alpha, this part. So this is where I am hitting cos minus theta, which is a reflection of this here. Now the x coordinate is cos minus theta and y coordinate at this point is sine minus theta. And this point is theta. So here x coordinate is cos theta and y coordinate is sine theta. Are you guys with me so far, or I'm getting you guys more confused? Praneet, Dheera. I did not do anything fancy, okay? Trust me. What I did was, I was just trying to wrap my head around this one. What does theta and minus theta mean here for us? If this theta is from here, it makes 180 degree or pi radian, and then this angle. What will be my cos minus theta? I'll go in the clockwise direction 180 degree plus this angle. And this point and this point will be right above each other because this angle is in this direction, this angle is in this direction, rest of the things are same. So here the x coordinate of this point and this point will match. So cos of theta will be equal to cos of minus theta. See, because if your x coordinates, the x coordinates are matching, right? This is also negative, this is also negative, same value, this is common. So your cos theta will be equal to cos of minus theta. So C is also an option. Am I being able to make you guys believe it, or I'm still just proving myself? Samriddhi, making sense, beta? Sure? 100% sure? No, I'm not always right. I'm just trying to see if the way I'm thinking, is it making sense to you or not? Make sense, beta? Vishal? Praneet, okay? So this is the right option. Now let's look at what Praneet is saying. Praneet is saying B is right. Okay, so if Praneet says B is right, so what is, okay, so now let's look at, let's do some cleanup here.
Sir?
Yeah.
Are we considering for A instead of B?
You'll be considering A. And can you explain this to all your friends and me, why you're thinking so?
Because since you have 2 pi would be essentially sending you back to the
Same
start,
place.
and plus the pi, which would just bring you back to where it already is, of theta, plus the theta, which would get you to cos of theta.
Okay, since Dheera is new to this whole topic, so Dheera, tell me, whatever Praneet said, were you able to relate to it? I'm trying to convert you all into a storyteller, okay? Whatever you tell, if that goes as a story to everybody, you will be well heard. So Dheera, were you able to relate to what Praneet said?
In all honesty, I'm a little lost right now.
Okay, so that's why I'm here, okay? That is why I'm here, to get you more confused. Okay, so let's look at it. What Praneet is saying is, whatever Praneet said, okay, that will become a generic rule of thumb for us. Okay, let's look at it. This is my unit circle. What is my first rule of unit circle? That says any point you pick up, the coordinates of that would be cos theta, comma sine theta. Dira, you agree with that? This part is okay? And how much is the angle in radian if you're looking at the circle? 2 pi. 180 degree equal to pi radian. These are two different units of measuring angles, correct? Yeah. So we are looking at this whole circle. We are looking at 180 degree, that is 1 pi, and then this is another pi. So 180 will be 1 pi. So now what Pranesh is saying is, if you are looking at theta, any angle theta. I know this is different from the question we had, but I'm still trying to generalize it. If you are looking at any angle theta here, your coordinates will be this, cos theta comma sin theta. Now you rotate by 360 degree, meaning you come back to this point again. So you started from here and made a complete circle. By how many angles in radian you moved? 2 pi radian, correct? And you landed in the same place. Yeah? Is that okay? So you had angle theta and you revolve around this center by another 360 degree or 2 pi radian. You land in the same place. Yeah? You circle around this one more time, meaning another 2 pi plus 2 pi or 4 pi. You landed in the same place. You make one more rotation around this. You landed in the same place. You make one more circle. You landed in the same place. Is this okay so far? Yeah? So, this, and again, any point you come to, you will find out your x coordinate is this length and y coordinate is this length. Unit circle only helps you visualize where you are landing after whatever angle you are trying to make. So basically, any angle theta, if you add 2 pi to it, you are landing in the same place one more time. 4 pi, same place. 6 pi, same place. 8 pi, same place. 10 pi, same place. So every 2 pi angle that you talk about, you are landing in the same place. So, cos of theta, this time our angle was theta. This whole thing here to here was theta. Now if you are adding 2 pi to it, you are landing in the same place. Your x and y coordinate value will remain the same. So this becomes an obvious pick, not this one. So we saw that cos of anywhere, any angle that you talk about, if you are seeing any of the option is adding 2 pi to it, you are landing in the same place, your x and y coordinates will be the same. So here, your cos of theta and cos 2 pi plus theta will always be the same, regardless of any complexity in the problem. So one option is already gone. This option is gone. Now I picked up this option. Randomly, I was not too sure. We just looked at, okay, if this is theta, what is minus theta? So then we navigated negative direction and in the clockwise direction and we landed here and we saw that, okay, whether I'm here or here, my x coordinate values are the same. It's not changing. That means my cos theta and cos minus theta are the same. So we got two answers already. If you think about this one, this will not be correct. Look at it. If this is theta, you are here. Theta plus pi, meaning you are talking about reflection. Okay? I mean symmetry. So you are going to this point and landing somewhere here. Look at your x coordinate is here positive and here your x coordinate is negative. So cos theta after adding pi is positive and before adding pi was negative. So they are not same. Similarly, if you are talking about cos pi minus theta, so basically you are going in the, okay, so this was your pi and then you are going minus theta, so this much and somewhere here. So again, this is negative and this one is positive. So basically you have to visualize it, okay? When you are looking at this kind of questions, first thing you have to do is Anywhere you have option of 2 pi being added to the angle, you're landing in the same position. That is done. Other options that you are seeing here, you have to just visualize that, okay, what does this angle mean? Which quadrant I am falling in? If I am talking about this quadrant and this quadrant, I mean, let's say if I am talking about y. So here, if my both the options are falling in this first and second quadrant, my y value will be the same. Both are positive. That will be the same. If it's falling here, my y value is positive here, it's negative here. X value is positive here, negative here. If you look at these 2 points, your x is positive here, x is negative here. So you'll have to visualize that, do the sketch, rough work, and then you'll be able to relate. Am I tolerable so far? Everybody able to follow me? Samriddhi? Sahib? Okay, Vishal? Vishal has been quiet today. All okay? Let's look at few more problems, okay? So one shortcut that we found was that if you have an angle and you're trying to compare that, if you are, any of the option is having 2 pi to the angle, 2 pi being added to the angle, that becomes your obvious pick. And then you will go through the question in detail to see if there's any other option that you want to eliminate, okay? Now let's look at some more problems. So again, you guys must be thinking that, okay, the concept of symmetry and periodicity, whatever rules that we learned, without memorizing that also we can solve it. And the answer is yes. Because symmetry and periodicity just tells you what it means, how you relate. But then actual magic lies in how you visualize it and draw it. Dira, you have some energy left to fight with the next problem now? And Dira, again, I'm not picking on you. This is a very normal problem with all the kids joining for the first time, because I purposefully do it just to make sure that the kids get a little comfortable, and I also get some insight into what you are comfortable with and where you would want me to stress a little bit more. Okay? Yeah? Dira is thinking, where did I get trapped? Okay, let's look at the next problem. We have another unit circle. This time I will let you guys struggle with this a little more. And bear with my drawing skills, okay? This is x-axis, this is y-axis, this is 1, this is -1. This time we are given a little friendly option. This is point which says 0.2, 0.98. Okay? And when you join these two, this angle is given as theta. Now reading the question, okay? On the following unit circle, theta is in radians and tan theta is equal to 0.98 by 0.2. Okay? Which is equal to 4.9. This is what the question says, okay? I mean, there is no brainer though, but I'm just reading the question as is. Without a calculator, evaluate the following expression to nearest hundredth or as an exact ratio. 10 pi minus theta, then 10 2 pi minus theta. So what this question says is, this is the angle theta and the coordinates are 0.2, 0.98, and it says, and theta is in radian and tan theta is equal to 0.98 by 0.2. See, in the unit circle, this is your sin theta, this is your cos theta. What is the big deal about it? Tan theta equal to sin theta by cos theta, 0.98 by 0.2. Same thing it's repeating to get us confused, okay? There's nothing tricky about it. Which is equal to 4.9. Now it says, without using a calculator, evaluate following expressions to the nearest hundredth or as an exact ratio. It says find out 10 pi minus theta and find out 10 2 pi minus theta. Are you guys able to give it a try? Tan pi minus theta and tan 2 pi minus theta. Okay, let me at least help you guys visualize this. This is theta. So minus theta will be how much? Just a reflection of this one. So this same, okay, not this one. Bear with bad drawing. This will be negative theta, okay? It says tan 2 pi minus theta. So 2 pi, this is minus theta. So basically 2 pi minus theta means 2 pi plus minus theta. Now we have got this. We'll add 2 pi to it. So we are talking about 2 pi to it. So here 1 pi, 2 pi. So basically when it says tan 2 pi minus theta, it's talking about tan minus theta. Okay. Similarly, tan pi minus theta, this is your theta, and it says pi minus theta. That means tan pi plus minus theta. So here you have minus theta, add a pi to it. So it's talking about this point, this line, straight line. So where if this angle is theta, this angle from here to here in terms of value it will be same theta. Now I have done half of the work, at least from visualization point of view. Can you guys help me find out the value of these two? Tan pi minus theta, tan 2 pi minus theta. Are you guys giving it a try? Samriddhi, Davik, Praneeth, Vishal, Sahib, Tira. Give it a try, go wrong, that's okay. Or you guys are still wanting me to repeat the question one more time for you? No response. Praneeth, are you clear about the question? Praneeth, Dida, Davik, everybody?
Yes.
Vishal, are you clear? Yeah.
I think I got one of the answers.
Okay.
For tan of 2 pi minus theta, I think it's negative 4.9.
Okay. How about Samriddhi? Give it a try, because I want you guys to go down. I don't take pride in you going wrong, but I want you guys to go wrong now than going wrong in the examination hall.
I'm still thinking about it.
But at least the visualization part is okay, right? We were talking about tan pi minus theta. So pi plus minus theta. Minus theta I'm measuring clockwise. So this same value of the angle, but in the negative direction. And then I'm adding a pi to it, meaning I'm talking about this symmetry, where this angle will be equal to this angle, which is nothing but same as theta. Okay? And similarly, 2 pi minus theta is nothing but 2 pi plus minus theta. So minus theta and then 2 pi to it. I'm coming back to the same point here. Okay. I'll give you guys 2 more minutes and then we will do it in the simplest possible way. I call it the lame option. And Dhira will think that what kind of teacher I'm stuck with, who always talks about lame options, or teacher himself being less intelligent. So Praneeth, what was your answer for?
For tan of 2 pi minus theta, I got negative 4.9.
Okay. Okay, we'll see. How about the other one?
I'm still doing that one.
Okay. Sahid, what's going on there?
Yes.
You're doing it?
Yeah, I'm doing
Yeah. Do it. I mean, we have to solve problems shamelessly, okay? Going wrong is fun. Even if you go wrong, that's okay. Yes, Pranit.
For the first one, I also got the same answer, negative 4.9.
Negative 4.9.
Yeah.
Okay. Anybody who is still working on it needs 30 more seconds, or you would want me to give it a try and explain to you guys? Samriddhi, Vishal. Vishal has been very quiet. What happened to her?
You can give it a try.
You can give it a try. Okay. Now, so one more thing, Dira, I will again bother you. Okay. How comfortable are you with the concepts or the theorem of congruency of triangles? Have you come across theorem of congruence for triangles?
Not in pre-calc, but in geometry, yeah.
No, these are concepts. Okay, I don't know when I learned these things. I did not do pre-calc, I did not do this thing, but yeah, these are concepts. Okay, I mean, I learned it in my mother tongue. I'm teaching that in English now. Okay. Okay. So yeah, I mean, it's the same concept. Okay. So these are same thing. So there's one theorem I will keep pouncing on it over and over again, and that theorem is RHS. Do you remember what is that? RHS is a theorem. As you can read, R stands for right angle triangle, H is for hypotenuse, and S is for one of the sides. So what this theorem says is, if you have two right angle triangles, they will be congruent if they have matching hypotenuse. For right angle triangle, if they have matching hypotenuse and one of the side matching, let's say this side and this side matches, then they are congruent, meaning every other property will match. Agree? Everybody agrees, including Theta? Okay. So now, let me do this in the worst or the simplest possible way. We are talking about, this is the unit circle. Okay, my drawing will get you guys baffled a little bit, but bear with me. So this is the point given, 0.2, 0.98, okay, and this is the angle theta. This is the angle theta. So let's first decode. Let's look at pi minus theta. Pi minus theta is nothing but pi plus minus theta. What will be minus theta? I will take the same angle and reflect it across this x-axis. So this angle is theta, okay? This angle is minus theta, sorry. So when I say pi minus theta, what I am talking about is, this is minus theta, I am adding pi to it, meaning the symmetry thing. This angle here is pi minus theta, okay? This whole angle, pi minus theta. Now look at two triangles. This one, drop a perpendicular from here to here, drop a perpendicular from here to here. What do you see between these two triangles? What do you see between these two triangles? your hypotenuse is matching, okay, and okay, it is applying other theorem of we can use other theorem congruence also. So this is angle theta. Let's say, let's give it a name. This is AOB. This is COD. So we are talking about triangle AOB and triangle COD, this one. And I am saying that these two are congruent. And why so? Because if this is 0.2, this is my cos theta. If this is 0.98, this is my sin theta. So that is why my tan theta is sin theta by cos theta, 0.98 by 0.2. That's what we are seeing here. Same way, if you find this length and this length, I'll be able to find out the cos and sin theta, cos and sin of pi minus theta, and I'll divide sin pi minus theta by cos pi minus theta, and that will be my tan pi minus theta. Okay? Is that okay? So this is theta. We are trying to find, we found that this is pi minus theta, this angle here to here. So this point's coordinates will be cos pi minus theta and sin pi minus theta. Correct? So we are trying to find out what is the value of cos pi minus theta. That will be nothing but this length. What will be sin pi minus theta? Nothing but this length. Let's look at these two triangles here. And I am saying these two are congruent. Now you will ask me why. Because, now look at this. There are other theorems of congruence also which says ASA. Meaning if you have two triangles, regardless of what type of angle we are talking about, if you have two triangles where two angles and the side between them is same, they will be congruent. Between these two triangles, these two are radiuses. So they are same any which way. This angle is 90 degree, this angle is 90 degree. So two angles have matched. Now this angle and this angle also same. I mean in terms of magnitude, okay? Because this angle is theta, this angle is same value, same angle, magnitude wise. Theta and this is opposite angle. So these two sides are crossing each other, these are opposite angles. So this will be same value as theta in terms of magnitude, okay? So this angle same, this angle same. So this angle and this angle has to be same, no question about it. Now you have this angle same, this angle same, and the side between them same. So two angles and the side between them are same. So these two triangles are congruent. Now we know this length and this length are same, this length and this length are same. But this is positive, this is negative. What is this length? So if this length is 0.2, here to here, 0.2, this is what we are seeing. This length will be minus 0.2. If this length is 0.98, this length is also same. And same 0.98 only. There is no negative here because both are in the positive side of y. Are you guys able to relate, or I'm just going too fast? Let me just do a recap again. So what we did, this is theta. This is 0.2, 0.98. From that, the question also says it's tan theta equal to 0.98 by 0.2. Sin theta by cos theta. 0.98, 0.2. What we did was, we tried finding out what is pi minus theta in terms of angle. So this is minus theta. Add pi to it. This is where you are landing for pi minus theta. If this is pi minus theta, the coordinates will be cos pi minus theta, sin pi minus theta. But anyways, let's not worry about it. This is the point. We just draw the perpendicular here. We are trying to find out the relationship between this triangle and this triangle. Because if you know this height and this height, we can find out this height and this length. We can find out tan pi minus theta. Here we anyways know. Now between these two triangles, we found that these are congruent because these two sides are same. Both are radius of the same unit circle. Both are 1. And then this angle and this angle same because it's a reflection of this guy and it's opposite angle. So this angle will be same. These two 90 degrees, so this angle will match. So now between these two triangles, you see these two corner angles are matching and the side between them matching. So these two triangles are congruent. So this length and this length are same. This length are same. So this is 0.2. This will be minus 0.2 because this is on the negative of x-axis. This is 0.98, this is 0.98. Now let's look at 10 pi minus theta. So we found that this length is minus 0.2, which is nothing but my cos pi minus theta. This length is nothing but sin pi minus theta. We got the magnitude, we are just mapping it with this. So 10 pi minus theta will be equal to sin pi minus theta by cos pi minus theta. Sin pi minus theta is what? 0.98 by cos pi minus theta minus 0.2. So it will be 4.9 but with a negative. Was I able to explain it okay? I mean, did you guys able to, were you guys able to follow it? And it's a test of my skills. Since you have not dealt with unit circle much, but you have geometry concepts, I'm just trying to relate to it and see if I'm making sense to you. And these concepts, I'm going to come back to it again, so don't worry about it, you're not losing anything. But I'm just checking my ability to see if I'm going to explain it okay to the kids who have not dealt with it enough. Is it making sense better?
Yeah, it is making sense.
Davik, Sahit, Vishal, Praneeth, Samriddhi, everybody okay? Same way, now if you look at 2 pi minus theta, same thing. Oh, this is so messy, I cannot do Control Z. So we found 10 pi minus theta is minus of this value. Let's look at 2 pi minus theta. So here, same, let me draw it again. This is theta. This is theta, this is theta. This is 0.2, 0.98. Okay. Now, what will be 2 pi minus theta? So again going back to minus theta and then add 2 pi to it, meaning coming back to same place. Now, this again, I'm not doing the same circus one more time. What I'm saying is, now you guys have seen. What we'll do is, we'll prove that this triangle is also congruent. Same concept. This is theta, this angle is also theta in terms of magnitude. Angles matching, this 90, this is 90, and this two angles will match, and these two sides are common. So this triangle are congruent. What we see is, my cos of theta is same, my sin of theta is positive here and negative here. So for this point, my coordinates will be cos of 2 pi minus theta, comma sine of 2 pi minus theta. And cos 2 pi minus theta is your x coordinate, sine 2 pi minus theta is your y coordinate. Here it is positive, here it is negative. Same thing. So 10 of 2 pi minus theta will be equal to sine of 2 pi minus theta, which is this one, negative of whatever value you see here, negative of 0.98 divided by cos 2 pi minus theta, which is same positive, 0.2. So this one will also give you 4.9 but with a negative. Time to breathe. But are you guys able to relate to it now? A little bit. Yeah? So, even if whatever I did in the last class, no matter whether you recall everything from that class or not, whenever you are dealing with a unit circle problem, the first and the foremost thing is how you are visualizing this. And then you break it down and solve it. Here you can say, okay, 10 theta, and now you'll go back to the concept of symmetry or periodicity that we learned. If you remember the formula, you'll say, okay, 10 theta is equal to minus 10 pi minus theta, or 10 theta equal to minus 10 2 pi minus theta. If you memorize that formula, you can do it in 10 seconds. But why do we have to memorize formula? This can be solved actually. Again, when I was explaining this to you guys, I took a little longer because I had to break it down. When you are solving it by yourself, right? Then as soon as you create this picture, okay, this is theta and this is 2 pi minus theta, I'm coming here. So my x coordinate remains the same, but my y coordinate changes. If I'm talking about 10 theta, sin theta by cos theta here is positive, sin theta by cos theta here will be negative. Same value, done. It will not take more than 20 seconds. But it will take you a lot of stress if you have to struggle with yourself to memorize all these formulas and you go wrong with one attempt to memorize, the whole thing goes for a toss. But when you are visualizing it and thinking about it, chance of going wrong is less and doesn't take much time. I mean, it'll hardly take you 20 seconds more. That's it. Do you guys agree? So, in the same, I had given you, I had put 3-4 more problems from the unit test that we do after everything in the Khan Academy. So, I had picked up the problems from there. What I would suggest is, go to the Khan Academy, pick up this unit, try solving few problems by yourself. And even if you're going wrong, sky will not fall for sure. Okay? Try it a couple of times. And then, depending on how comfortable you guys are, we'll pick up this thing in the next class. Okay? If not, we'll move on to inverse functions in the next class, not today. Is that okay? Sahib, Davik, everybody okay? So have fun then. See you guys in the next class. Alright? Bye, beta. Bye, everybody. Bye, Dhira.